The speed of light is 3 times 10 to the 8th meters per second. So as you can tell, light is very fast. 3 times 10 to the 8th meters per second. If it takes 5 times 10 to the second power seconds for light to travel from the sun to the earth. So just let's think about that a little bit. So 5 times 10 to the second, that's 500. 500 seconds, you have 60 seconds in a minute. So 8 minutes would be 480 seconds. So 500 seconds would be about 8 minutes 20 seconds. So it takes 8 minutes 20 seconds for light to travel from the sun to the earth. What is the distance in meters between the sun and the earth? So they're giving us a rate, they're giving us a speed, they're giving us a time, and they want to find a distance. So this goes straight back to the standard. Distance is equal to rate times time. So they give us the rate. The rate is 3 times 10 to the 8th meters per second. So it's 3 times 10 to the 8th meters per second. That right there is the rate. They give us the time. The time is 5 times 10 to the second seconds. So times 5 times 10 to the second seconds. Seconds. I'll just use that with an S. So how many meters? So what is the distance? What is the distance? And so we can just reassociate these, or actually move these around from the commutative and the associative properties of multiplication. So this right here is the same thing. And actually, you can multiply the units. That's called dimensional analysis. And when you multiply the units, you kind of treat them like variables. You should get the right dimensions for distance. So let's just rearrange these numbers. This is equal to 3 times 5. 3 times 5. I'm just recommuting or reassociating these numbers. So 3 times in this product, because we're just multiplying everything. 3 times 5 times 10 to the 8th times 10 to the 8th times 10 to the second times 10 to the second. And then we're going to have meters per second. So we could write meters per second times seconds. Times seconds. And if you treated these like variables, this seconds would cancel out with that seconds right there, and you'd just be left with the unit meters, which is good because we want a distance in meters, in just meters. So how does this simplify? This gives us 3 times 5 is 15. 15 times 10 to the 8th times 10 squared. We have the same base. We're taking the product, so we can add the exponents. So this is going to be 10 to the 8 plus 2 power, or 10 to the 10th power. Now you might be tempted to say that we're done, that we have this in scientific notation. But remember, in scientific notation, this number here has to be greater than or equal to 1 and less than 10. This clearly is not less than 10. So how do we rewrite this? So we can write 15 as 1.5. This clearly is greater than 1 and less than 10. And if to get from 1.5 to 15, you have to multiply. By 10. One way to think about it is 15 is 15.0, and so you have a decimal here. Where if we're going to move the decimal 1 to the left to get us 1.5, we're essentially dividing by 5. Then we also, if we're moving the decimal 1 to the left to make it 1.5, that's essentially dividing by 10. Moving the decimal to the left means you're dividing by 10. If we don't want to change the value of the number, we need to divide by 10 and then multiply by 10. So this and that are the same number. Now, 15 is 1.5 times 10, and then we have to multiply that times 10 to the 10th, not x to the 10th, times 10 to the 10th power, this right over here. 10 is really just 10 to the first power. So we can just add the exponent. Same base, taking the product. So this is equal to 1.5 times 10 to the 1 plus 10 power, or 10 to the 11th power. And we are done. This is a huge distance, just so that you can, well, it's actually it's very hard to visualize. But anyway, hopefully you enjoyed that.